Alright, time for a new topic. This topic is a very broad one. It's going to take us a while to get through this one, so bear with me. Here we go, starting with static electricity. Now the topic is electricity, and we're going to spend, like I said, quite a long time on it. We're going to start with static electricity, and I'll explain what that is in a minute, and some basic electrical concepts. So that's all we're doing in this video, some basic definitions, basic concepts. A lot of it I'm sure you already know. So we're just kind of reviewing, won't take too long to go through this. So, introduction. What we're going to cover is electrical charges and basics about static electricity. So, here we go. First thing, there are two kinds of electrical charges. First, well, it's arbitrary which one you say first, but anyways, first I'm going to say positive, and then second, negative or minus. So this is sometimes called plus, positive, minus, negative. And of course there are different things in the world that are charged positively, and there are different things that are charged negatively. So lots and lots of them in your body, in fact. So first thing you need to know, which you already know I'm sure from other classes and other things in your life, electric charge comes in two kinds, positive and negative. Something you may not know already is the units of that charge. Electrical charge is measured in a term called the coulomb. And yes, it's named after a guy who did work with electrical charge. Okay, so coulomb. Coulomb, right there, abbreviated as a big C. Okay. So that's the units of electrical charge. So if you say, if you want to say, oh, how much charge do I have? Then you might say 550 coulombs or something like that. Now that'd be kind of a lot of charge, but anyways. So coulombs, that's the measure of charge. 1 coulomb of charge is defined as the amount of charge contained by, get this, 6.24 times 10 to the 18th electrons. Or protons, charged particles. So an electron has a charge of, say, let's say it's 1, not 1 coulomb, but let's just say 1 unit. Then it would take 6.24 times 10 to the 18th units to make up a 1 coulomb. That's 1. 1 coulomb is this number. Now what is that? That's about 6.24 quintillion electrons. Yeah, that's a lot. So, anyways, that many electrons makes up 1 coulomb. And of course, your body has way more than that number of electrons in it, so you got way more than 1 coulomb of charge. Of course, you've got a bunch of protons as well that cancel out most of the electrons, so you're pretty much neutral on your body most of the time. Anyway, coulomb of charge, 6.24 times 10 to the 18th electrons, or protons. Okay, so now that we've settled the units of electric charge, and we've talked about the two kinds of electric charge, time to talk about a little bit about static electricity. Electrostatic repulsion and attraction. So you can have sometimes electrical charges just sit still, like a charged surface might have some extra charges sitting still on there, and that's why it's called static. They're not moving, they're sitting still. So if you've got this rod with a net positive charge at the end of it, and it's just sitting there not doing anything, then you can cause things to happen with that. Alright, so if you bring that near to a surface, like a metal plate, well, there's going to be some attraction and there's going to be some repulsion that occurs as a result of this static electric charge. The attraction is that the minus charges are going to be sucked up to the top of the plate. Right, up, out from this part, through here, to the top of the plate, so the plate is going to get a minus charge to match with the plus charge of this rod. Now, this only occurs, really, if you don't actually touch the plate, alright? So if you bring this close to the plate but don't touch, this has a positive charge, it attracts the extra electrons, they flow up to the top, bam, you've got attraction going on there. Now, that leaves a deficiency of electrons down here. It used to be balanced down here. If we look at this one, this is an actual apparatus. These are two little, basically like tin foil, but they're not tin, they're gold. So this is two pieces of gold foil, and they're connected up with this plate up here. So it's like all one big connected piece. I mean, it's not the same thing, but It's touching. So the electrons can be shared among all this metal. The electrons can flow around in there. So the electrons flow up toward this charged rod because they're attracted to it. That leaves a lack of electrons down here. So there's going to be now a positive charge down here on these leaves. And positives repel because they're the same. So the same charges repel each other. So that means that when these electrons run away, they're attracted up here to this positive rod. Yay, we're going to come up here and party. They left behind a positive charge, a net positive charge behind because they left. So these are now positively charged, and they repel each other because they have the same charge. So they're going to spread out like this. That's what you can see these gold leaves doing right here. I'll zoom in on them. Those leaves of gold foil are repelling each other because their electrons have run up to the top of that plate up there. They're up here on this plate, right? So that means that now there's a positive charge, a net positive charge left behind, and positives don't like each other, so they repel and they spread out. That's pretty cool. This is incidentally one of these things it's called an electroscope, and it's one way of measuring charge. So the amount of repulsion that you get here tells you how much charge there is there. So anyways, the point of even showing you this electroscope is just to point out, like charges repel, like these leaves, opposite charges attract, like the electrons that come up here and try to get to that positive rod. All right? Last thing, static electricity is generally caused or generated by rubbing or some other form of friction. Examples: sliding on playground equipment that is plastic, right? You slide on there, the clothing that you're wearing rubs against this plastic, there's an exchange of charges, electrons actually, and then your body either gains or loses, depending on the materials, either gains some electrons or loses some electrons, and then they might collect in your hair those excess charges and cause your hair to all try to get away from each other because they're all now charged the same. So maybe you've got a whole bunch of minus charges in your hair, like extra electrons, and they're all repelling each other because like charges repel. Anyway, so rubbing. You might also have walked around a house that has carpet and scuffed your feet a bit. It's not going to work very well in the Philippines because it's very humid here, and static electricity has a hard time sticking on surfaces when it's really humid. So you need really kind of a dry environment. But in any case, maybe you've scuffed your feet on some carpet and you've built up some charge and then touched a metal object and bzz, there's a zap of electricity. Well, that's because some extra charge had built up on your hands from the scuffing. So static electricity is usually generated by rubbing or some other form of friction. Now here, what we've got is a lesser known example of static electricity building up. This is a helicopter. The helicopter blades spin very, very fast in the air, as I'm sure you're aware. So as they're spinning, there is dust in the air. You can't really see it most of the time, but there is dust particles. Lots of little dust particles and other particles in the air, and those bounce against these blades. That bouncing of those particles against those blades causes a buildup of charge on the body of this aircraft. So that can be actually dangerous for people entering and leaving the aircraft if certain techniques are not observed. Now, there is a way of eliminating that static charge, and there's a video about that I might show you in class. But anyway, they have to equalize the charge that's built up on this helicopter before anybody could get on or off of the helicopter. Because otherwise, the person getting on or off is going to be the conduit for the zap of the electricity getting off of the body of this helicopter. So anyways, bottom line, because of the rubbing of these blades against dust particles in the air, charge builds up. Similar to the way that charge builds up on this little girl because she slid down the slide. Friction with the surface of the slide caused a buildup of charge. Now, not all friction with all surfaces causes charge to build up, but sometimes it happens. Okay? That's it for this introduction to electricity. We'll be doing lots more with that. Thanks for watching, and we'll see you next time.